Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, TuneIn Radio, or add our RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, and please give us feedback. You can leave a review on iTunes to help other people find the show, send us a tweet or an email, leave us a message on Google+, or in the comments in our show notes, and we've also started a new discourse forum at discourse.pythonpodcast.com, where you can join the community to discuss the show. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. Linode is sponsoring us this week. You can check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. I would also like to thank Hired, a job marketplace for developers and designers, for sponsoring this episode of Podcast.init. Use the link hired.com/podcastinit to double your signing bonus to $4,000. Your hosts as usual are Tobias, Macey, and Patti. Today we are interviewing Maciej Fijalkowski on RPython. Maciej, could you introduce yourself, please?
Hi, I'm Maciej Fijalkowski, and I live in Cape Town, South Africa, though originally being from Poland. And for the last 10 or so years, I don't actually remember, I think I started in 2006. I've been a core developer of the PyPy project, which also includes the RPython toolchain.
So, Maciej, how did you get introduced to Python initially?
How did I get introduced to Python? I have very hazy memories of that. It was sometime during studies, I think. I was at the time working in Perl. Not sure if anybody here remembers Perl as a language.
Of course.
It used to be a thing. And Perl, while a wonderful tool, has serious problems with scaling to larger projects. Like the projects become clunky, the object orientation is never very good. So I was looking at other languages to see what can be higher level than C, because I never felt like dealing with strings in C is a fun exercise. And not Perl. And that's how I ended with Python.
What is RPython and how does it differ from CPython?
So RPython is a very strange language, which generally should not be recommended to people to use, but it has been used for a very specific purpose. Notably, it's a language for writing interpreters. And this is essentially this is where the difference starts. RPython is a static subset of Python as a language. And as a static subset, it's amenable to compilation into C or LLVM or assembler, the lower level languages. It's an ugly language. You should not generally use it, but generally speaking, Python is not great for system programming. Like you wouldn't want to write an operating system or a virtual machine or language platform in Python because, well, it's too high level. So that's how RPython got introduced. It's a strange mix of low level features, static analysis, and a good bit of magic to make sure it all works.
And you said that it's a static subset, so is it implemented in C? And is the syntax at all similar to how you would write Python, or is it completely foreign to somebody who's used to Python programming?
It's proper subset, so every valid RPython program is a valid Python program. But the way you use it is very different from normal Python. Like you can't use most libraries, you can't use dynamic features. Most of double underscore methods don't work, except init and del and a bunch of others, but generally they don't. You can't mix different types. They have to be static. You don't write the types yourself, but they have to be static enough in order for our Python to figure things out and compile it to efficient C. So the compiler itself is written in Python, but it compiles RPython to C, so it's detached from the Python runtime once it's compiled. So introducing this step is also a major difference between Python and RPython.
And can you share some of the history of RPython in terms of the major improvements and design choices that have been made?
So RPython started as a very strange project. Like, not sure if you remember the project called Psycho.
I've heard of it briefly, but it's been a while.
Psycho was a just-in-time compiler for CPython precisely, and it was replacing the inner loop with small special code that would optimize into assembler. And Psycho had a lot of problems, and one of those problems was that it was trying to encode in the just-in-time Python language. Python, contrary to popular belief, is actually quite rich and extensive language. I always have a slide that says that you can't fit on one slide the exact rules of addition, how it actually happens, like which method is it under add or under error. Does depend on the types, classes, descriptors, everything. It just doesn't fit on one slide. So there's a lot of semantics in Python, and we sat down and decided, okay, we want a simpler language, and we want to. That's not exactly how history happened. It was more accidental, but it might as well. We want a simpler language, and we want a statically compiled language that the just-in-time compiler can be written for without too much trouble. And then we're gonna use the language to implement Python interpreter. It is PyPy, and then we would use that to generate just-in-time compiler for the interpreter written in RPython. So one of the problems is that if you write this stuff in C, C is not a very good target for static analysis. Like, say, if you look into CPython source, you have incref and decref sprinkled all over the show. Like, every single file has thousands and thousands of manual reference counting. And it's really hard to do. So what we did is said, like, no, we don't want that. We want a language that we can automatically analyze and look at the graphs and then say, okay, those flow graphs have those properties. We can insert this garbage collector or that garbage collector depending on the details. And we don't want to encode like incref and decref all over the place. This is how RPython got created, as needing a slightly higher level language than C, but lower level than Python. And at the time, there was nothing really comparable. I remember it's over 10 years old, so it's before things like Go and Rust were even introduced.
And in the documentation, it says that RPython is able to generate a just-in-time compiler for dynamic languages. Can you explain why that is significant and some of the ways that it does that?
So it's done as I described previously. It's because you can write an analysis step for RPython flow graphs. You might as well write one that generates a compiler. And this is, so you write your interpreter in RPython, interpreter of any language, ideally dynamic language, because this is what the interpreters are good for. And RPython toolchain, through looking through the graph and thinking about it really hard, would generate a just-in-time compiler for that. So you have one input that will create an interpreter that is compiled to C and runs like a normal standalone executable, but it will also be able to dynamically emit assembler code specialized for your language. So that's something that has seen quite a bit of uptake, and there is a project that does the same for JVM called Truffle. It's for Growl JVM, and it does exactly that, except instead of using RPython, you use Java.
Yeah, I can recall I listened to an interview with some of the PyPy developers a while ago, and one of the questions that was asked is how many JIT compilers there are in PyPy, and the answer was that we don't know because they get generated dynamically. So I thought that was kind of a curious statement. So I don't know if you can dig into that a little bit more about how those get generated on the fly.
Well, for example, if you think about Python, you would think that there is only one bytecode really there, but there are more. Like, there is bytecode for regular expressions, and that gets another JIT generated. There is another bytecode somewhere else that does something slightly different. And since we have all the infrastructure, we might as well generate the JIT for that too. So, like, for example, under PyPy, regular expressions are much faster than under CPython because we have a JIT that got automatically generated. We didn't even need to write it.
And with a JIT, is it possible to reuse the compiled code if you stop and restart a service, or is it rebuilt dynamically every time a program runs?
It's definitely rebuilt dynamically, and we were discussing, like, can we do something about it? Can we store and save and restore the state? And it's generally quite difficult, partly because Python is such a strange language where it's very difficult to say, is this module that I imported the same one as before or not? Like, you can't just compare code because it has constants, and the constants can be get from anywhere because import statement can execute very arbitrary Python. Like, there are no limits. So unlike, say, PHP, where there is a very well-defined boundary between compilation step and the runtime, in Python it's all intermingled together. So if we can solve that question somehow, we could potentially think about storing and restoring the data. But right now, no. Right now, you need to warm up it again each time you run a process.
And so the most well-known use of RPython is the PyPy interpreter. Can you share some of the other languages that have been ported to the RPython runtime and how their performance has been improved or altered in the process?
So there has been a lot of experiments. I don't think any of those has seen much actual adoption. But there has been HippieVM, which is a virtual machine for PHP. There is Tobias, which is a virtual machine for Ruby. And there has been numerous scheme interpreters and tons of other things that they generally show that improvements are possible and you get them for relatively cheaply. There's definitely one about Racket. It's called PyCat. PyCat, I don't know. And that one is undertaking some serious development. And you can see how, like, what the other thing you can see from that is how difficult it is for a new interpreter to make its way into the community. You need to run most of the packages. Like, you need to be able to run extensive libraries. You need to be able to somehow compete with the deployment story, etc., etc. So it's not that easy to introduce a new interpreter and just hope everybody picks it up.
Yeah, there's the adoption curve can be a tricky one to overcome for, as you mentioned, an interpreter, but also for even just new packages or entirely new languages, because there's always the initial trepidation of, oh, is this stable? Is this actually going to stick around? And you sort of have to just keep plugging away and make sure that it stays visible long enough for people to finally get over that hesitation and concern and actually start using it and feel confident that they're going to be able to continue using it far into the future.
We've seen complaints about PyPy that PyPy is not shipped with some random arbitrary version of Red Hat. And this is something that's impossible to fix without a time machine, essentially. Like, no, it won't accidentally get shipped with a version of Red Hat that was released in 2006. Like, it's just not going to happen. So those sort of problems are things that you need to overcome, and sometimes it just means waiting.
Yeah, patience is definitely an important attribute in software, despite the rapid rate of change and how quickly somebody can re-implement an idea. You know, it's definitely important to remember that patience is valuable as well. So, are there any languages that have been designed entirely for use with RPython rather than translating an existing language to run on it?
I'll finish the last question with the fact that most language platforms move much, much slower than your average software package. Like, all the languages that we use, not all of them, obviously, but most of them are at least 10 or 20 years old. Like, C is really old, Python is really old. Even PyPy, which is the new kid on the block, has been around for 11 years. Even V8, that's like this brand new JavaScript engine, has been around for like 5-6 years, something like that. So it really takes a long time for it to pick up. To answer your question about the languages that have been designed entirely for use with RPython, I think Pixie is the biggest example. It's this sort of Lisp, I think. Pixie Lang. I haven't looked at it, but I've seen people talking about it. I have absolutely no idea what it does, to be honest. But there definitely has been things. I just don't hear every single use of RPython.
Yeah, that's definitely a common theme that we've heard a number of times in our interviews, as well as, just in general conversation, is that for any open source package, it's difficult to keep tabs on the usage and sort of how well represented or people's experiences with it unless they're negative and they come back with a bug report. So do you know of any cases where an application has been written to run directly on RPython rather than via one of the interpreters that are based on RPython?
No, and I hope I'll never see one. RPython is really not that great language.
Okay. So it's theoretically possible, but highly discouraged.
Yes. It's definitely highly discouraged. RPython is a bit like C++. You can write books and books about tips and tricks on how to do things, and there will be people like very different ideas. What's really RPython, what's not that cool RPython, etc. Yeah, not necessarily.
And what are the computer architecture and operating system platforms that RPython supports? And I'm wondering if you have any plans to extend that support.
So we are expanding this quite rapidly, actually. So as of now, the trunk supports x86, PowerPC 64, and ARM without ARM 64, and OS X, Linux, Windows 32-bit, and to an extent FreeBSD. We have ongoing work for S390X, which is a mainframe architecture. So PyPy is getting industrial ready or enterprise ready. That's the term. But yeah, we are expanding this to pretty much anything that can run software these days, except tiny embedded devices, which are just too small for that. So probably we'll see MIPS at some point and RISC-V, and that will cover the entire range of architectures that you actually want to support these days. That's not legacy hardware.
Right. Yeah, you definitely have to have some cutoff point of how far back you're willing to support things, because I can't imagine anybody wanting to run PyPy on a 486 or the even older 8086.
I think we ship, the default version requires SSE version 2, which has been introduced in Pentium 3 or Pentium 4. And there have been complaints that it doesn't work on specific hardware, which is already like 2 decades old or like a decade and something. I don't know. I don't know exactly when it was introduced, but a while ago.
You'd be surprised how many people end up backporting all kinds of crazy things to, for instance, the Amiga. But that it's certainly understandable that you wouldn't want to support every crazy archaic architecture out there.
Yeah, exactly.
And aside from the CPU architectures, are there any minimum space or RAM requirements they're necessary to be able to run a language written against the RPython platform?
It all depends on the details, but RPython and all the interpreters are garbage collected languages, so you would want at least a couple megabytes of RAM. If you have a platform where RAM is really scarce and you have some kilobytes of RAM, you can write an RPython program for that, but you're going to run into trouble. Like, things will try to allocate and it's impossible to allocate. Like, you wouldn't write a program that has to run in fixed amount of small memory. That's exactly what C is for.
Mm-hmm.
So is Python similar in concept to other efforts like Parrot in the Perl world?
No, Parrot tried to do what JVM does, which is provide a common platform, common virtual machine that speaks one language, and then everybody would just compile to this high-level platform and be happy. And this doesn't seem to be working very well. The same goes with JavaScript these days. Like, you can compile any language you want to JavaScript, but you either have to choose your language has to be like JavaScript. I don't mean syntax, because you can change that. But semantically, either has to be like JavaScript or will it be very, very slow. So you have this semantics mismatch that makes it very difficult to compile certain things to a different high-level virtual machine. And this is what Parrot tried to do, and this is where it failed, because it turns out it's impossible to find a reasonable common subset, because everybody is different. If you write stuff in RPython, you can write anything. We've seen people writing an ARM emulator in RPython, for example, and it was pretty decent. It wasn't as fast as the fastest ARM emulators out there, but it was much less effort. The fastest ARM emulators these days have use jitting technique to achieve like reasonable performance on x86, by the way. But it was faster than any sort of interpreted ARM emulator out there. So people have done very, very different stuff. And it's very difficult to think how would you write an ARM emulator that compiles to JVM and is actually fast.
Yeah, with the recent advent of WebAssembly, that whole idea is sort of getting revisited in a slightly different light, and then also in a slightly different context, LLVM can be sort of thought of as a common compilation target as well.
Well, LLVM is yet another something completely different. LLVM can be thought of as portable assembler. And it's definitely a notable goal. Like, you want the portable assembler. It's great because having 7 different backends that emit things that are mostly similar but slightly different and definitely not compatible is annoying. So LLVM is, but that's about it. LLVM won't give you more tools. Like, it won't come with a garbage collector. It won't come with a just-in-time generator. And stuff like this. So this is an entirely different project. It serves its niche, and the idea is that you can compile anything to LLVM, which is this low-level assembler, but only one and not n. While RPython is you use RPython to write stuff. You don't want to use LLVM to write anything. Like in LLVM bitcode, you'd probably write in C++ or C.
For anybody who's actually interested in using RPython for their own work, what would be your recommendation for getting started?
There's documentation. There's a collection of blog posts about how to write your own interpreter. Just Googling around should give you enough documentation to get started. It's a good middle ground, as in you probably won't get as much performance as writing a very custom cut assembler generator like LuaJIT, but also will be massively better than your first interpreter written in C. So it's this middle ground where you will get most of the speed at relatively minimal cost.
And are there any particular areas of the project that you need help with, and how can people get involved with that work?
People can do, well, RPython is an umbrella project for a lot of things. Like, there is some research done on software transactional memory. There is project on providing numeric computing on the RPython platform, etc., etc. Like, there's a lot of different projects that, and generally, I would suggest that people scratch their own itch and try to make things that they're interested in, and that's usually the best way to get involved. Like, find a problem that interests you and then see how it fits in the project.
Yeah, software transactional memory is definitely a very interesting area of research, and I don't know if you're able to dig into that a little bit. I know that that's one of the ways that PyPy is attempting to create an answer for the parallelism problem.
So software transactional memory is very interesting because it's this sort of project where, let me start with explaining what it actually does. So the idea is that you write your code, and as long as the code doesn't do any I/O, you optimistically parallelize a couple threads of execution, and then if they come into conflict with each other, you roll back one thread. So to the user, it looks like you're running a couple of threads with one gigantic log. So it's much easier to reason about, but it's a better way to write software, essentially. Now, the problem is that with the current hardware and the current level of knowledge on how to do things, you're still paying a relatively high price for the software transactional memory. Like, we haven't been able to get consistently below 2 times the cost. And that's too much for some people, or in fact for most people. So it's a kind of strange project where if you can't get the single thread performance within certain range of things running without the software transactional memory, you have this really interesting research project that doesn't do anything useful. If you can get it within, say, 20% of the cost of single threaded, you now get parallelism for free, and that's a new model to think about software, and this is completely revolutionary. And there's middle ground somewhere in between, and the middle ground depends a lot on, I would say, engineering, but there's a lot of science involved in how do you actually want to do it. Can we get some support from hardware? There has been definitely attempts to do that from Intel with introduction of hardware transition memory, but it comes with its own set of problems. So how do we do that is a very open and interesting question. And if somebody solves it, it will be a new way how we think about parallel software, I think.
Yeah, I'm definitely intrigued to see how that ends up turning out, because if we could get cheap and easy parallelism in Python, I think that would assuage a lot of concerns that people have about the future viability of Python in the face of some of the new generation of languages.
Yes, I mean, STM gives you something more than just multiple threads being able to run at the same time, because people have multiple threads in C, and as far as I know, everybody tries to avoid this like fire unless they absolutely have to, because it's a major nightmare to deal with, and to debug problems, you can't write the reasonable test to check if there are no race conditions, for example. So that's why STM is so interesting, not just because it gives you multiple threading, but it also gives you a better way to think about software.
So are there any questions that we didn't ask that you think we should have, or anything else that you want to talk about before we move to the picks?
I think one interesting thing to think about, which I've been thinking a lot about myself, and definitely is about PyPy project, but not just about PyPy project, is that the question is, how do we pay for open source? How do we make sure that open source is developed in a way that's independent of large companies and in a sustainable way? Because open source is just so much better way to develop software. Then it's so good that we really don't see much of, like, all the language platforms that are proprietary essentially died or went open source. Otherwise, you can't survive in this world. So that's something that I don't have any actual answers, but I think it's an interesting question to ask.
Yeah, it's definitely one that keeps recurring, particularly lately. I've seen it crop up a number of times, and as you said, it's not an easy question to answer, but definitely an important one to continue thinking about and try to come up with an answer for. And like you, I don't have a solution for it yet, but perhaps we can have a future episode to dig into that idea a little more deeply.
I really liked Eric's solution when we had him on for Read the Docs, actually, where he basically said that Read the Docs and other such things are effectively utilities, and as such, the companies that utilize them should pay into them. And I think programming languages are similar, right? I mean, it's very hard to get companies to recognize this and to be willing, but I think it's a good idea in any case. And yeah, we should do an episode on that. It's a great plan.
I like the idea of making companies pay. I don't know how you would go about this, though.
Yes, right. Exactly.
I agree that's utility, but the main problem, I think, is probably the answer is like multiple ideas. But like the main problem is that these days, if you talk with companies as an open source developer, they're going to talk with you from a marketing budget perspective. Their contribution to open source is marketing for them, unless the project becomes so essential to their business that they essentially take over. And it's only possible with very large companies like Google or Facebook when they just take over gigantic open source projects because it's essential to their existence. But we want them to look at this as investment for the future, like something that's engineering effort, not a marketing effort. That's a major shift in view that we are missing here. Because they don't consider open source engineering. They just consider it something that exists there and you can throw a few dollars and make it a good marketing tool.
I'm sure we could spend all day debating the relative merits of various plans, and it's definitely an important conversation to have, but I don't think we'll come to a conclusive answer. So with that, I will go ahead and move us into the picks. My first pick today is going to be the PyCoders 2015 recap. They went back through the past year of their weekly newsletters and pulled out all of the most common projects and articles, and it's just a really good resource to get a high-level view of the different things that happened in the community over the past year. So a lot of good information, good utilities. Highly recommend checking it out. My next pick is going to be a 3-in-1. So I recently picked up an Xbox One for the family, and I got it with the Kinect sensor, and I also picked up the game Shape Up, which is it uses the Kinect for its play, and it's a gamification of different exercise routines. And I have, I have children who are occasionally high energy, so it's a good way for them, when it's raining outside and they need to move around, to get them to spend some of that energy. And it's also fun for the wife and I to play with them and against each other to, just play along with the games, because they're very entertaining and there's a lot of humor to the different scenarios. So we've been enjoying that. It's a good way to encourage you to do the exercise that we all know we should be doing. And for my last pick, I'm going to choose the movie Selfless. It's an interesting sci-fi movie that came out recently, and the basic premise is that there's a very rich individual. He's dying of cancer, but he is approached with the possibility of transplanting his consciousness into another body. And he's initially told that the body is grown in a vat, genetically engineered, and so there's no, loss of human life or effect to any other people. And at the risk of ruining the story, I will stop there, but definitely worth a watch. And with that, I'll pass it to you, Chris.
Cool beans. So my first pick is a Tumblr. Now, I know a lot of people think Tumblrs are basically just memes and other, frivolous crud, but that's absolutely not the case. This is the NPR's science Tumblr, but it's really interesting, very visual, very cool. It's great stuff. You should check it out. My next pick is a card game in the category of card games that are really, really simple, that you can sort of teach to people in a matter of a couple of minutes. The rules can be described in a single sentence, but there's actually a fair bit of depth and strategy there. Which I really prize that kind of thing, because my wife won't play anything else. So I was really happy to find this. It's called Category 6. That was the version that I played. It's known by many other names. The original name was called 6 Nimit. It's really neat. It's basically you have to place cards in a column, and you're trying not to place the sixth card, and each card has to be numerically greater than the last. It's just a lot of fun. My last pick is a CD or a recording. I've had this CD probably since shortly after I first got my CD player in like 1988 or so. So it's old, but it's really good. I'm one of those people who sometimes likes to fall asleep or work to environmental noises, the sound of rain falling, the sound of a thunderstorm, the sound of a meadow, and the various sort of electronic generated approximations thereof just don't do it for me, because I have really good hearing and I know what these things actually sound like, and the fake versions just sound horrible and wrong to me. And this CD is some really amazing recordings of the outdoors. It's called Environments, and I really love it and haven't found anything better than it to this day. Actually, I'd love it if anybody has other recordings of this kind of thing that they like that are more recent. And that's it for me for picks. Maciej, what do you have for us?
I was presented with the list of picks a bit on the fly, but I'll go ahead and try with PyCon South Africa. I would happily invite people to come over to the beautiful city of Cape Town. It's rough. I don't think dates are set yet, but it's usually October. So that's when places like East Coast or Europe get really grey and just not fun to stay at. While Cape Town has a beginning of summer. We get like over 300 days of sun each year, and just a lovely place. And that's it from me.
All right. Well, thank you very much for taking the time out of your day to join us. And for anybody who wants to keep track of what you're up to and follow what you're doing and what's going on with the RPython project, what would be the best way for them to do that?
Well, we are usually very active on IRC, so just find us on the Freenode, and that's the way to get hold of most of us. If not, then the mailing list is the main place. We also run a consulting company around PyPy called baroquesoftware.com, and we do various extensions and improvements to both PyPy and RPython if your boss finds it interesting.
Great. Well, thank you again, and I hope you enjoy the rest of your day. I'm sure everybody will enjoy learning some more about RPython and how it relates to PyPy.
Thank you and have a nice day.